So far I discussed about that data transfer instructions in the instruction set, and now I need to move for the arithmetic instruction. So before going into the detail of this arithmetic instruction, as I had explained by the end of the data transfer instruction, that there is no impact of the data transfer instructions over the flags in 8085. But in further, for the arithmetic instructions as well as for the logical instructions, there will be effect of this instruction execution over the flags. So it means after the execution of these arithmetic instructions or logical instructions, there will be the reflection of that data or the result, whatever it will come after performing that, will be shown by the use of these flag registers. So that is the reason at this point, before going into the detail of these arithmetic instructions, I must have to discuss about the flags used in 8085. So first of all, we should know about that these flags is having 8 bit of the register. So here this is given, this is here 8-bit registers. This is 8-bit register, and as I hope you are knowing about that ALU. So this 8-bit register in 8085, it is the part of the ALU. So especially in the ALU, there are 4 major components, which is called as a accumulator, temporary register, arithmetic and logic circuits, and flags. So whatever the arithmetic or logical operations happens, based on that, as a result of that operation, the result is stored into the accumulator. At the same time, based on the results of that operations, it means by the use of that arithmetic instructions or by the use of logical instructions, there will be changes or there will be reflection of that result over the 8-bit flag register also, and result will be stored into the accumulator part. So especially in 8085, we are having 5 flags. This is available in 8-bit of register, but mainly we are having 5 flags here. So these 5 flags will change or will modify as per the result obtained after the performance of this arithmetic or after the execution of this arithmetic instruction as well as logical instruction. So here these 5 flags are called as a sign. This is called here, S means sign. So this is called sign bit, and here this is taken as a D7. So whenever we are performing with some sign bit operation, or whenever we are doing some operation with a sign number, by that time after performing that operation, whatever result comes, so as per the result, if their MSB bit as a D7 is 1, then the sign bit will be updated as a 1, and by that time that result will be considered as a negative number. Remaining 7 bits will be showing the magnitude over there. Now if the result is coming here, if the D7 bit of the result is 0, by that time this sign flag will be 0, and that indicates here that number is positive. Now this D6 bit is shown here as a Z. So this is the flag which is called as a 0 flag. So this 0 flag will be set or reset as per the result obtained after performing the operations by the use of this arithmetic or logical instruction. So for example, after doing certain operation, if the entire result, it means if the 8-bit result is coming as a 0, then this sign, then this 0 bit will be 1, otherwise it will be 0. For example, let's say we are doing here subtract A, SUBA. So what this instruction will perform? This instruction will perform that whatever is having the content in accumulator, the result like this will be performing the subtraction from the same register itself. So here if this accumulator is having, let's say as a 04H. So 04H means we can show it here 000 0100. Now we have to subtract the content of accumulator from the accumulator itself. It means here we need to subtract this 04 itself. So here if you will see that if we are going to subtract this, then their result will be 0 here. So here the result is coming here as a 0. It means it is saying that this 0 flag will be set if the result is non-zero. Non-zero means it might be positive, it might be negative. So if the result is non-zero, then this 0 flag will be reset. So here we can say that this will be 1 if result 0, and here this will be reset if result not equal to 0. So this is the functionality of this 0 flag here. Now if you see that this D5 bit, it is shown here cross. Cross means no used or it is not used, and this is kept it as a reserve. This has kept it as a reserve. So as like D5 bit, D3 bit and D1 bit is shown here with this X symbol. So these 3 bits are not used so far. It has kept it for the future requirement if it is. So here that is the reason D5, D3, D1 is not used. Now we'll talk about that D4. So D4 is assigned to this AC. AC means auxiliary carry. This AC means auxiliary carry. So here when it is going to use, so whenever let's say this is D0, this is D1, this is D2, this is D3, this is D4, this is D5, this is D6, this is D7. So whenever we are performing any kind of arithmetic operation, and if there is any carry generated from this D3 bit, from this position, from D3 bit, if any carry bit is generated, it means it is going to set this auxiliary carry. So here if carry generated from which position? From D3, then AC is set, otherwise reset. Otherwise it will be 0. So now the next point is that next flag is here as which is assigned to this bit position as a D2. So this P is called parity. This P is called here parity. Parity flag, or we can say that parity bit. So this will be reset based on the result obtained after performing certain arithmetic or logical operations. So here whenever any arithmetic or logical operation performed, as a result of that, if there are even number of ones, in the result, then this will be set, and that is called as a even parity. So here we can say that if even number of ones, then set. For odd number of ones, it will be reset. So it's very simple, like whatever operation we are going to perform, whether it is arithmetic operation or logical operation, as a result of that, in the result, if there is even number of ones, then this parity bit will be set, and if it is not even, it means it will be odd. So if there are odd number of ones, then this parity bit will be reset here. So let's say in this example itself, if someone will ask that what will be the status of this parity bit, so if you see that as a result of this SUBA, this result is having all zeros. So all zeros means there are 0 number of ones. So many times students answer this as a wrong, like they are saying that it will be 0, but here zeros number of ones is called here as a even parity. The reason behind that, as a normal number system, you might have seen 0, 2, 4, 6, 8 and so on. These all are even number. So if there is no 1, it means it is having 0 number of ones. So 0 number of ones is giving the indication that this parity bit is performing here as an even parity, and this parity bit must be set here. Now, the next bit position for this D naught is having the next flag, which is called here as a carry flag. So this CY means it is called here as a carry. This is called here as a carry. So whenever we are performing the arithmetic or logical operation, by that time, if there is any carry generated, if there is any carry generated from the MSB bit, then this carry flag will be set, otherwise it will be reset. So basically this carry flag is used whenever we are performing the arithmetic operation of two larger 8 bits. So whenever we are performing the addition of two larger 8 bits, then there might have the chances that the result cannot be accommodated with the 8 bit of the accumulator register. So due to that reason, this is going to update this carry flag. So this carry flag is storing that 9th bit of that result over here. So if the result is not more than that 8 bit, it means if there is no carry generated from the MSB bit, then this flag will be reset. So here we can say that if carry generated from D7 bit of result, then CY will be 1, otherwise 0. Otherwise it will be 0. So here you have studied about that there are 5 flags in 8085. Coming from left, it is having sign bit. Then what it is, their use already I had explained. So sign bit, 0 bit, auxiliary carry, parity bit, and carry flag. So these are 5 flags especially used in this 8085, and I hope you understand these flags in 8085 in the better way. Thank you.